And here we are. Marty, take it away.
Thank you, Paul. I'm Marty Feldman. I am the section chair of New England, and I want to welcome all of you to a joint meeting tonight of both the New England section and the New York section. We've done that a couple of times now, and Zoom makes that possible. Where is Ed DeLotta? Is he here? I don't see him on the screen, but I want to thank him for helping to make this possible. He is the section chair of New York, and delighted to have him with us tonight. Tonight's meeting is kind of a continuation of the development and evolution of IP production and how it fits into everything else that we're currently doing and what we will be doing eventually, I would imagine, pretty much exclusively, and that's using IP for live production and pretty much everything we do. Hopefully using, at least the industry hopes, we're going to be using enterprise type equipment, especially for routing and switching and that sort of thing, and that should be a cost saving for the ownership. Our speaker tonight is someone we're delighted to have coming all the way from across the pond, depending on where you're listening to this. You could be listening somewhere in Hawaii, but it's Andy Rayner, and he is the Chief Technology of Nevion. Now, Nevion, I'm told, 18 months ago became part of Sony, and they will be exhibiting at NAB coming up, and Andy is flying out on Friday. Should be a good show. Unfortunately, I can't make it this year. So Andy sits on many boards. He's a SMPTE fellow. He's a broadcast technologist. He's responsible for the design of BT Global IP Media Network, and oversaw the development of key video interfacing, monitoring, and protection technology. That's an interesting one. So as I said, we keep getting deeper and deeper into IP, and it'll be probably a somewhat long transition, I would imagine, away from SDI and everything else that we're doing, but a very interesting transition indeed. So it's my pleasure right now. Oh, one more thing I want to bring up before I get into the introduction, and that is I also want to thank Joe Schmizzi from Sony, Dion LeConte from Sony, and of course Ed, as I mentioned, the section chair of New York. And at this time, I'm going to turn it over to Andy, and I would expect a very interesting evening. Thank you, Andy.
Greetings. Thank you very much, sir. And good to be with you this evening. I'll do a little bit of an intro to the topic as we go. What I'm going to do now is I've just started, hopefully, sharing the right screen. Can you just confirm that is, Martin, that's good? Can you see my screen again?
Looks good.
Wonderful, wonderful. Okay, let me kick off. It's great to be with you here. And yeah, coming to you, just jumping through here, just so you can see where I'm speaking to you from. We're on the East Coast. I'm just about 1 mile from the sea on the East Coast of the UK down there. So it's just gone midnight in the UK. So where I'm speaking to you from is actually where I'm now Thursday already. And which means tomorrow I'm flying out to the US for the first time in 2 years to join many of you, hopefully, at NAB. So great to be with you, and thanks for the opportunity to share with you this evening. So just a couple of bits of background, 2 or 3 slides of background on where I've come from and etc. and the organization I'm part of before we jump into talking about the technology. So first of all, Nevion, where I'm the chief technologist, is very passionate about standards. We're very involved in lots of elements of standards, both within SMPTE and many of the other standards bodies. And that's something that we feel very strongly about, and is part of I would say, the DNA of the way we work at Nevion. Also, just to say, in terms of resources, if you're interested in lots of technology exposition and tutorials, then I've done, this is just a few examples. I've done a whole load of those, which are available via the Nevion website. Also, we've got a free to download tutorial book, and this is not like a Nevion product push at all. This is very much a technology exposition book about baseband to IP to virtualization, and it actually unpacks a plethora of topics related to the area, some of which I will touch on lightly this evening. And the last slide of context, which Martin's already alluded to, is Sony acquired Nevion about 18 months ago. So we're going to be at NAB. I'm going to be at NAB as part of the Sony stand, which is in Central Hall, 10901. So if you want to check me out there, do come over there. I'll also be speaking several times throughout the show in various places, such as the IP Showcase, which is in one of the West Halls. And I'll put the details for that on, as well as my contact details at the end of this webinar. So if you want to get in touch, do please reach out. It'd be great to talk to you and catch up with you. Okay, that's the like overview done. Now let's like dive into the topic for tonight, which is about live production, distributed live production, and the evolution to that. And this picture is going to be, I'm going to refer back to this towards the end, because this is really my go-to, which describes, I think it's a catch-all. It's a very high level, obviously, but it describes all of the key elements that I see are gradually coming into the way we do live production. And first of all, it's IP. I'll unpack that in a minute. Secondly, it's distributed, as you can see, and things like COVID, I think, have actually really helped accelerate some aspects of that. Not that it wasn't happening beforehand, but things have been pushed more aggressively because of that. But what we can see here from this block diagram that I've shown on many talks, because I think it is a very, very good context slide before we dive into anything. First of all, and very important, the management layer at the top that's actually orchestrating all of these elements. But then you've got everything from what I would call your traditional central facility on the right-hand side, your typical event location, if you're thinking about doing an event production, bottom left. You've then got private or public cloud data center hosting of infrastructure, which is largely speaking processing and storage in whatever form that takes. That could be generic server, or it could be appliance-specific functionality. Top left, you've got 5G, the emerging, and I'll touch on this again briefly, emerging high bandwidth, high QoS capable technology to allow us to actually be very, very agile and flexible in wireless connectivity into production. And top right, by no means least, I think in the US, the term at-home production means like at the central facility. So what that home there means, top right, is the domestic home. We've actually seen the real enabling of people being able to actually be part of a significant part of a live production, literally from their own dining room or study or garage. So this I think is a very important overall block, because I think that gives you the context. And what I would say is with the technologies that are now becoming available, the only limitation we really have within the whole of this infrastructure here is the speed of light in fiber. That's the only fundamental mathematical restriction that's actually that dictates some elements of the way we need to construct solutions to make them work. But having said that, the speed of light in fiber is pretty fast, so we can actually do an awful lot within this context with very little trickery needed to work around it. But we'll unpack some elements of that a little bit later on. By the way, I'm intending to actually allow some time for Q&A at the end, but also I'm very happy to be heckled, but as we go. But I'm kind of guessing from what Martin was saying that probably what we'll do is I'll talk for maybe about 40 minutes, and then we'll open up and if have plenty of chance for people to talk. So do jot down your questions and save them, and we'll talk about them at the end. So that's the context with my nice building block diagram here. What I think is really important is to actually consider what content producers are looking for. And in my very, very, very simple picture of this is as follows. There are two main things that I see production content creators wanting to do. First of all, they want to ever increase the production value. I think we've seen some fantastic demonstrations of the production value of both events and traditional programming and studio-based programming. All of those things really, really lift because of the capability that we have. So production value increasing is something that people are always looking to do. And the other, if you like, contrary requirement that's forever being driven is the desire to decrease the cost of what's being done. And these are very important. They're very high level things, but they're very important when we come to look at the flow of what's been happening with IP production. And if you like, both of those things, the increased production value and the decrease in cost, is driven by a desire for more flexibility. So the flexibility is flexibility to actually work, flexibility in the way things are charged and the way the costing is done for you, flexibility in the way you can just do more things and therefore increase your production value. So I think that probably sums it up very well. We're going to rattle onto this, and I'm just going to reinforce this message in a couple of different ways in the next couple of slides. But IP can be transformational when it's used in its full extent. And I think the dipping the toe in the water of just converting IP facilities, so converting production facilities to IP, which has been happening for the last, 6 years or so, 6 or 7 years, that doesn't really leverage the full advantage of IP, because IP really only comes into benefit when you can actually make use of that flexibility to start sharing stuff, that stuff being most importantly people, but also real estate, be that the studio floors, the galleries in different locations, and also all of the processing equipment that's needed to create a production. So bear that in mind. We're going to come back to that a little bit later on. Also, and again, I think Martin alluded to this in the introduction, what we are very much starting to do, and the intent of moving to IP, or part of the intent of moving to IP apart from the flexibility, was that we're gradually moving in many spheres of broadcasting, from the bespoke to the generic, and that's everything from the from the stuff that we're going to be focusing on today, like things like have already been mentioned, the IP switch fabrics, the compute servers, but also even the cameras, such as the camera, the camera on my latest iPhone here, which is absolutely phenomenal, and actually can serve a very valuable part of a live news gathering element contribution for live content production. So there's lots of very generic elements that are coming right across of technology right across the sphere that are able to contribute into live production. So this is a little picture that I've been using for 2 or 3 years, and what I want to demonstrate here, and I'll unpack it in the next slide a little bit more, is what we've been doing for many years. When as Martin said, before I joined Nevion 11 years ago, I was head of technology for BT, the service provider in the UK, the largest service provider in the UK, and was architecting many IP networks. So we actually put a global IP broadcast network in coming up for 20 years ago now. So IP wide area networking has been well proven. And IP local area networking, as in IP facility, production facilities, as I said, probably the early ones of those came in maybe 5, 6, 7 years ago. What we're now seeing, and the real benefit leverage that we're getting, is actually the convergence of those two things coming together. So it's actually interconnecting of IP-enabled facilities with IP-enabled wide area networking, and the combined capability there means we have a very, very significant flexibility. So that's the place that we're coming to, and I'd like to unpack a bit more. So let's look a little bit at the journey of that production flexibility from the elements we've been talking about there. So on the left-hand side, you can see what I call the Ip1 infrastructure. So 20 plus years of this being matured in the industry in general, by many people, across all of the continents of the world. And one of the key things that was doing was starting to leveraging the ubiquity of IP connectivity as being used in service providers. Also, the use of that kind of technology actually allowed us to create very new and more innovative resilience techniques within the way we actually provide connectivity. Also, massively increases the flexibility of how we route things compared with fixed SONET or SDH TDM infrastructure. We can suddenly do so much more if we're actually IP centric. And service continuity as well, disaster recovery, all of those elements, the ability to be able to be so dynamic in reconfiguring connectivity in the wide area network meant that invoking service continuity, disaster recovery, things like that was also incredibly useful. So that's step one. That's quite old now and very mature. IP facility infrastructure. So I've got a few bullet points on there, but just transitioning without any of those other benefits I've already been talking about, but just transitioning to IP gives us resilience in the way that we can very easily do what has become SMPTE 2022-7, an RTP layer merge technology, which has become pretty well ubiquitous in all deployments, I would say. It gives us, it makes us completely agnostic, largely speaking, to the spatial resolution we're using, to the temporal resolution we're using, the bit depth, the color gamut, the number of audio channels, the metadata, all of those things which were very specific with an SDI interface suddenly become much more generic. The only real limitation then is the total bandwidth that's available in terms of potentially restricting the upper end there. And that in its own right, without any of the other benefits I'm alluding to, already created significant flexibility in, for instance, having, if you've got a production facility with multiple galleries and multiple studios, being able to dynamically route between them has meant it very, very easy to make more use of sharing galleries, sharing studios between galleries and other booths, etc. All of those things have been stuff that happened in the early sphere of the take-up of IP production before it was what I would call distributed. The third bullet point there in the sort of greeny color, teal color, complete IP end-to-end. This is the point, this is where we're at really at the moment, I would say. In the last 2 years, in my experience, we've been moving into this sphere. And this is very much where we're talking about being able to share those resources, the people, the real estate, the processing, anywhere to anywhere. And that's not now just restricted to within a campus, an IP facility, but actually, we can share a truck, we can share different galleries, different studios in different places within a country and internationally as well. We can share that processing. We've recently done a project with an e-gaming company, a very well-known West Coast US-based one, who are effectively creating 3 follow-the-sun 8-hour time displaced production centers. So actually, as you go round go round the clock, you can actually have people in their native time zones actually working on the content and the production as needed. Service continuity obviously is also extremely flexible then, because you can actually share and route between distributed resources in various locations. And I've got a few case studies that I'm going to very briefly touch on later that will expand some elements of that. And then what we're moving into now, which is still largely speaking, for most people still to come, is what I call virtual IP end-to-end, where actually most of that data processing and connectivity and routing is effectively cloud-based, certainly is entirely software-based. And that actually gives us the ability to dynamically scale, because we don't have to own all the resources. We can actually move to very different commercial models, because we can move to different OpEx type models, which wouldn't have been available to us in a traditional plant. And also something that's very close to my heart is we can actually start to do true convergence of live production with traditional file-based production. Traditional nonlinear editing, because as all of the infrastructure becomes completely software based, live just becomes to some degree a special case of an NLE environment. That's very much simplifying things, but I just want you to think about those elements. So I think those are key bits. And just to expand that last bit about the convergence, typically we have a common acquisition approach, at an event or at a production where we acquire stuff. We have the traditional low latency live production workflow that we work through. We typically then have some people working on what I call near live highlights NLE, which is the in-program highlights production and other bouquets of stuff that need to be created within the program. And then you've got your more traditional longer term craft production. But as I said, as we move that live production workflow at the bottom to be what I think will be eventually a complete software model, then actually it becomes far more convergent with some of those other strands above. So just looking at this kind of that last element, that virtualization element and the software place, just one comment on that before we dive back into some of the more detail on distributed production in general. But this is my very rough workflow of everything that happens within, or the key things that happen within an IP production, from the acquisition at one end to the emission, and then obviously post-emission, the consumption at the far end. And what we're seeing is the virtualization, the softwareization of this and cloud-centric approach is really rolling back from the back end of this. So we've actually been doing cloud-based emission and software-based emission for a long time. I think even the conservative broadcasters of the world are actually viewing that their dominant audience is effectively OTT delivered. So it's internet delivered rather than being delivered over the traditional digital terrestrial satellite cable type channels. Playout has actually been maturing for a long time in the in cloud and software basing. So most channel playout is now entirely a software based proposition. We're at the stage now with a lot of MCR functions, are starting to move into this cloud centric environment. And the reason I think that's important is because the MCR is the first time that we're actually now talking about latency really mattering, and that real time really mattering, because the other elements, latency per se has not been critical for playout and emission so much. So we're now starting to move there, and some elements of lower tier production are now starting to be viable and done indeed on software based infrastructure. So we're rippling back around that. But moving back to the distributed production I was talking about, in the next few minutes, we're going to look at some of the aspects of this, the enablers, the challenges, and then some use case examples of what we're seeing. Before we do that, I just thought I would have a little bit of fun just for 1 minute to actually talk about a picture I came across many years ago. But this has been within my career lifetime. I think I started with BT my career in 1988. This drawing is from 1990 or updated in 1990. It's available in the public domain. It's available on the internet. And this is a picture of all of the connection points that existed within London and how you did. So this was all coaxial, and the longer the connection was, the more degradation there was. And you can see there were some relay switched elements, but there were lots of these were done on jumpers. So literally the way you did connectivity was jumpering through from one location to another. And some of you that are familiar with London will recognize several of the locations, from Westminster Abbey to 10 Downing Street to the Royal Albert Hall to Earl's Court, all of those things on here. That were done to actually be able to interconnect and get connectivity to key places. So, this was, if you like, a precursor to distributed production, by being able to do things from these different locations, be that productions or just injects. Anyway, that's just a diversion for a few seconds as a point of humor. This is another one of my go-to pictures, and I just want you to bear this in mind, because I think this sums up my view of where we're heading as an industry. So we have been very, very focused on what I call a linear production chain ever since, well, almost 100 years ago, broadcasting of television started. We've been very focused on, effectively a raster-based linear propagation of a television, of a video signal as part of television, and all of the processing equipment that we've had in the chain, right up to and including the way we've done ST2110 in SMPTE, has been driven by that linear timing and the timing models that support that and dictate that in the way we do. My premise here is that will change. We are always going to be acquiring content, the cameras, the microphones, in real time on the left-hand side there. We're always going to be consuming it in real time on whatever devices that is, whether that's lean back on a TV or lean forward on a tablet or phone on the move. And the production people, those involved in doing the production, obviously will be needing to view or listen. In the gallery, they need to view all of the video in real time, and in the audio booth, they need to listen to it in real time. But all of the processing itself, will not need to be locked to this raster architecture. And in fact, compute, native software doesn't really work well with the kind of linear, uber linear, raster centric world that we've grown up with and propagated in the way we've done television for the last 90 plus years. And more and more, and we're starting to see that significantly in the industry already now. As we move to software production, software needs different ways of communicating and talking and sharing data. And I might talk a little bit about that if we have time a little bit later on. But that's where we're heading to. So that green block, which is all of the processing end to end, that covers all of those bits I talked about previously, that doesn't need to be linear propagating like we're used to. It needs to be time aware. It needs to absolutely be time aware of every little element of the different types of media that are involved in it. But it only needs to be in real time for the consumption of human beings involved in the production, or at the very end when they're actually viewing the content. And that's a very, very different mindset that we need to change to. And I think this mindset is a bigger transformation than anything we've done in moving from NTSC and PAL to SDI and SDI to IP. I think this transition that we're now heading into is even different there. Getting back to these distributed production that we're focusing on tonight. The DPP did some great work early last year, which I was privileged to be part of, on analyzing the different ways, and this is kind of event centric, but I think this is generic enough for us to consider classic studio production architecture as well. But the three main like icons or sets of icons within this, the dark blue is the acquisition and display elements. The light blue is the processing and storage, and the orange is the control. Those are the three fundamental elements. And as an example, thinking in event-centric, on location, typically with a truck, you've got all of those things there. You've got the cameras there, you've got the storage and processing, and you've got the operators all present. The second one down there, the remote controlled, is the kind of architecture we saw a lot of during COVID, because it was the people we wanted to remote in. So quite often we still had the trucks there at the events, or the infrastructure in the studio that's doing the processing and storage, etc., alongside the acquisition devices. But a lot of the people doing the operation, the control, were remote. Centralized is the concept where you've got, which is a lot of what I think we call REMI, or at-home production, where you've got the acquisition devices in one location, and then you've got your processing, storage, and operators all together at, typically at a central facility. Distributed, that fourth one down, is very much where you've got the acquisition in one location, you've got your processing and storage in another location, typically, a data center, be that a public or private cloud type data center. And then you've got your control elsewhere. The cloud one at the bottom is similar, but the actual storage is cloud there. And then we've actually added a couple of other models of slightly different scenarios that we've seen previously. One where effectively, and I think some broadcasters are looking at this, the additional models there, you've got your acquisition and control co-located, but your actual processing is in a data center elsewhere. That's becoming quite popular. And the bottom one there, private, just to point out the fact that it's not necessarily public cloud hosted. A lot of the benefits we alluded to earlier can be realized in a private data center environment. Okay, so let's look at some of the enablers to remote production, to distributed production, and how that's falling out. First of all, one of the enablers is available bandwidth to do stuff and the cost. So, in the UK, as an example, it's a nice small location. So, our top to tail latency down the UK is only 7 milliseconds. So we can get pretty well anywhere within the UK, within one video frame. So that's a pretty nice situation to be. I guess in the US, probably you're looking at needing to allow 2 frames if you're doing an east to west coast type connectivity. But the cost of bandwidth is forever falling, and the latency, as I said, is the only restriction, but that in itself is actually workable, roundable. And one of the observations I see on latency in distributed production, very much content creators, the creatives always want 0 latency, but as soon as something that gives them additional production value comes along, they're willing to absorb latency. I think one of the most quoted examples I've used in the last few months is sort of large UK-based sports production, where suddenly the concept of being able to do an augmented reality studio added immense production value and cost saving. And suddenly people were prepared to split the gallery with probably a half a second delay between 2 zones in the gallery, pre and post the augmented reality processing, which was typically, I don't know, 10, 12 frames or something, because it gave additional production value. So small amounts of latency can be tolerated, and I don't think we'll have time to go into it today, but what you can do is do significant elements of time compensation if you've got very long haul elements that you're doing within your distributed production. Another enabler, and I'm not intending to talk about this sufficient much in detail today, is obviously compression. very specifically, we are using a lot of JPEG XS, which is on the right there. It's what I call the mezzanine compression. And the reason that that's actually becoming extremely attractive is that it's very, very, very low latency. The actual compression latency is the order of maybe a couple of hundred microseconds each end, certainly sub-millisecond. So that pretty well, if you're doing any type of wide area, distributed production, that compression becomes negligible, and you can approach a 10-to-1 compression ratio with that technology. So that's very attractive. It's also worth saying, and I can say you can visit our booth to actually have a look at this, but there's some very, very low latency temporal compression such as HEVC evolving now, and we're going to have a couple of demos, I believe, to show how that matures at NAB if anyone's around would like to see. But anyway, compression is really playing a key role in there. Now also, the SMPTE suite of 2110 is ever evolving. We're actually working on a couple of new parts to the suite at the moment to actually enhance things even more. But that, what I call data plane SMPTE suite, combined with the NMOS tools, which are used for the control plane, have given us in the studio a very good set of interoperable standards-based tools for sharing flows and sharing the control of flows as well. And that's very important. And what I'm going to unpack just in a few minutes is looking at how we actually do that, or how we actually do this stuff when we're actually long distance. The other thing I want to say that's very, very important here is security. This has been possibly in some cases left as a last minute thing, or certainly not been, but security needs to be in there from the very start of the initial design right through the system. And again, us leveraging the best practice of the IT industry in general gets us a good long way into security, because security is first and last and everything else in between in decent IT rollout if you're an architecture. So we only really need to leverage what the greater, wider industry is actually doing to actually make sure security is fully embraced. If you haven't seen it before, I'd like to point you to something the EBU produced, which is the technology pyramid. And it talks about everything from, as you can see, the very top there, the media transport. Then it goes through several of the other elements. I'm not intending to unpack this, but security is down there as being, arguably the hardest thing to sort out correctly. But there's lots of other elements between that. But this is a really good reference point to actually think about what is needed and the different layers. So if you haven't seen that before, I'd urge you to look it up. You can Google it, the EBU pyramid. You'll find it very easily on the web. Okay, so moving to think more about distributed production that we've been talking about a bit. What are some of the challenges? And I think one of the biggest challenges that we have seen as we do this has been with scalability. Scalability has become quite insane within this, and there are various reasons for that, but it does mean that we need, in the way we architect solutions, to actually have explicit control to actually make sure things happen. And what's driving scale? So in terms of the scale of the actual switch fabrics, obviously the higher resolutions, the higher spatial and temporal resolutions. I have this personal view that higher frame rate is actually more important than the crazy high the crazy high spatial rates, like 4K and 8K moving up. I think there's vastly more quality we can do for the typical end consumer with a higher frame rate, but that's just a personal view there. But what we're seeing is, it says on the left hand side there, more signals in production, video and audio. One of the things we've done with 2110 in that toolkit is break up what would have been a traditional SDI signal, which would have carried the video, typically up to 16 audios, and possibly several ancillary data flows, to give us the flexibility in the production and the need to not route all of those everywhere. One of the key tenets of 2110 was breaking that up into essences, so we route things individually. So typically, we have actually scaled up, and we've got quite a lot more signals flowing separately in a network implicitly, because the video is separate to the audio, and the audio may be being carried as individual monos, more likely stereo pairs or groups, bouquets of 5.1 surround and things like that, but basically clumps of audio, and then the metadata and ancillary data is running separately. Distributed production at the bottom there is another thing that's driving scale, as I've alluded to, simply because you're now trying to actually share resources, and you're needing to be able to route and control and make use of resources, not just within your local facility, but make use of it elsewhere. One very simple example on scaling is just an observation I was looking at basically over the last kind of 10 years. So 10 years ago, typically in our control layer, if you like, for broadcast, it was the order of 1,000 like flows that we were switching. Typically, a good size SDI router would be 1024 squared or something, and that's what we would be using in a reasonable size environment. I know there were some bigger things than that, but that was where the scale. When we did a couple of deployments, maybe like 7 years ago, we were looking at 5,000 flows, and then probably 5 years ago, we were needing to be able to control 10,000 media flows. About 2 years ago, we got to the point of needing to control the order of 100,000 flows. And in stuff we're working on this year, that's doubled again to 200,000. This is not a linear scale here. Neither is it a logarithmic one. This is just a very simple noddy attempt for me to show that things are getting big. That's not to say that all of the requirements for distributed production are big. Some subsections of that, such as a production truck, B truck, may be relatively small scale. But scalability is something that's incredibly important. And as I said on the previous slide, one of the things we need to do is explicit routing and control, and SDN type architectures, which is something that we've spent a lot of time on, have something that's absolutely essential when you get to this level. And the other thing that's very, very, very important is abstracting the end user from the underlying technology. There is no doubt that understanding IP routing and everything else that goes alongside IP and addressing it, etc., is significantly harder than the concept of plugging things in and out of an SDI router fabric. And as we scale things up, it's just impossible to even manage on any level what's actually happening with the signal flow. So the end user has to be abstracted from the signal flow in these large networks that we're now moving to, and these distributed networks, to actually make it usable. So making it usable is very important. One of the things that we've done a lot of focus on is actually thinking about how we scale orchestration, how we actually scale the compute to make that work well. So even if you're handling 100,000 connections, how do you make that work effectively and scalably? And one of the things that we're starting to see the trend towards, as we start to actually look at multi-campuses and the true distributed production, and again, I've got a couple of examples coming up, is the concept that you actually have autonomous yet interconnected control systems. So you have a control system for a campus, and you have a control system for another campus. They can run autonomously, but they can also securely interconnect and share resources. And that's really important. So just to expand that, the concept is we actually have resilient control systems in each location. And I'm showing here like a cluster because that's the typical architecture we would employ nowadays. And those control systems can actually talk with each other over secure APIs to actually allow them to share resources. I think I've already alluded to the to why explicit routing and explicit control of signal flows is important. But just to, and I'm not going to read all these elements out, but just one overall comment is, if you grew up with like an AES67 or a Ravenna or what other bespoke audio multicast audio environment, then you may think, oh, why is SDN so important? But audio, when it started off, and the reason I'm using audio as an example is because it was ahead of the game. Digital audio has been a thing for a lot longer than IP video has. So IP audio, but typically you've got the number of flows you've got it can be high, but not too high for the bandwidth, the aggregate bandwidth, to cause any real problems in a reasonably dimensioned network. Whereas when you're talking about with HD, typically having video essences the order of 1 gigabit per second per flow, and if you go to UHD uncompressed, it's the order of 10 gigabits per second of a flow or approaching that. And that's assuming that's even at like 50p or 59.94p. Why? It's before we've gone to really high frame rate. So we've got those elements, but this is an important thing. I just want to give a little plug for some work that we've been looking at. So what you've got in distributed production, inherently you're connecting either a truck with a campus, with another campus, with cloud processing, and you've got two fundamental things that are happening in between, or you want to happen in between. One is the media flows themselves, and the other is the control. So basically you've actually got the ability to request and set up connections from one place to another. And that's, again, you see those padlocks there. The security, the way of doing that securely is very important. So we've been working on some of this work within the Video Services Forum, and which we're calling 2110 and we've just completed the first phase of work there in defining secure ways of those things talking and sharing resources across multiple locations in a secure way. And obviously a big part of that is the control plane, how you actually discover, register and control things. And in fact, the control plane has proved in the standards work we've done there to actually be the biggest challenge as part of this. Okay, I'm going to whistle stop you through a few. I've talked about the tech now. Whistle stop through a handful of examples of deployments, just to talk very briefly about a few elements of these. So this is an example. This was probably about 7 years ago. This is one of the first what I call distributed IP deployments in Europe. Two interconnected key locations, roughly like 200 kilometers apart from, so the latency is not extreme. In fact, speed of light in fiber coincidentally is about 200 kilometers, roughly takes 1 millisecond. So the latency is not crazy, but this was, there was significant resource sharing because one location was doing a lot of weekday programming, the other was doing a lot of weekend programming. A lot of shared resources there, shared studios, control rooms, etc. So that was a very, very early deployment where leveraging the benefit of the shared resources and sharing people as well was very important. Another slightly more recent deployment, which has happened in Switzerland, in Europe, is where we've actually had some IP facilities in multiple locations, and we've started to interconnect them to give that level of flexibility that I've been alluding to. So that's been, again, I'm not going to unpack it in significant detail. Just a couple of little diagrams here. I think this one's probably the best one, the full network overview, but it gives you an idea of the number of locations and what's happening there. Another quick example, just to rattle through a few of these. This is a pan-European multi-country network, which again really showcases the concept of sharing of resources. So 2 good data centers. These are private data centers, so this isn't a public cloud hosted infrastructure. This is private data centers in 2 different locations, 2 different countries. And there are actually 12 different countries that are making use of these centralized facilities connected via 2110. And in fact, this solution uses JPEG XS to give some mezzanine video compression for the international connectivity. This is a bit more of a breakdown of it between those 2 hubs and the different elements that we're looking at here. And if we break it down even more, just to show you here, the concept where we're using the JPEG XS to do the compression there. And we've again got this dual diverse capability, both in the infrastructure and in the connectivity to actually bring those things together. Another example slightly closer to home to you guys in the US. This is a US-based thing that we've been working on recently. And again, this is all about distributed production. It's about enabling different facilities to work together, accessing common compute and storage capabilities and allowing those things to actually be worked out. Also challenges in some environments. If you're in some kind of cloud environments, then unicast is needed rather than multicast, so you have to work through that as well. Also worth saying, one of the other challenges with distributed production, which isn't a real problem, but it's something that people have to get their heads around, is how to handle timing. So there's a couple of fundamental things. First of all, most plant nowadays has a GNSS reference of some kind, a GPS or whatever other GNSS reference that's used. So there is absolute time available and being used typically in each facility. But what you do obviously end up with is the risk that something is not locked to that, but also you have undoubtedly a definite phase offset between locations, because the speed of light in fiber we're talking about means you're going to end up with, potentially a significant fraction of a video frame offset when you actually reconcile into the next facility, simply because of the propagation time. So all of those things come into play. Just rattling around a few other quick things before we come into land here and I open up for questions. We talked about 5G. I've been able to do quite a lot of testing of various 5G infrastructure in the last few months as part of a variety of projects in Europe here. And it's been very interesting to look at how that's played and what the possibilities are. In very quick summary, I think there is immense potential from the use of 5G technology to actually give us really, really agile contribution capability and distributed production capability that can be truly pop-up. I've done some talks on this. If you want to check them out, it will give you an idea there of some of the challenges, but also the opportunities. I think another thing, if you think back to that original up the production value, lower the cost, give more flexibility, one of the things I think is really important that this distributed production enabling is it's enabling the previously unviable. So this isn't just about doing things better. This is actually meaning that some of those maybe what I would call tier 3 or 4 sports events that typically may not even have been able to be covered properly can actually now be covered with a multi-camera production because of the cost effectiveness and the flexibility that that remote and distributed production gives. I think someone's just come unmuted. Just in case you I can hear some noises somewhere on the system. One other thing that I just want to draw attention to, because there's a work package that I'm trying to chair at the moment. We've only recently started in the last couple of months, a SMPTE work package, which is going to be a -11 part of the suite of 2110, or is likely to be. And this is how we reconcile Essence timings. We talked about the benefits of splitting up, and carrying the video and the audio and the other elements all separately in the production, but in the plant. But they need to be reconciled, and we're looking at ways about doing this automatically, and that applies both within the plant, but it's even more critical when we're actually going between locations. And some of the recommendations in the 2110 work we did actually cover that as well. Very briefly, just touching on the cloud elements. So as distributed production is likely to become more and more cloud-centric in terms of specifically the processing and the storage elements, then the way we do connectivity and control in the cloud is very important. And the connectivity element very specifically, and the instantiation of resources, is something that's subject to quite a few different bits of work that are happening in the industry at the moment, to actually do that in a way that makes sense for software-based architectures. Again, not going to have time to unpack that now, but there's significant work happening, and I can point you to that if you like. This is just a reminder of that original picture of where I believe the end game is, but coming into a variation of what we've been looking at, that diagram that I showed you at the top of a fully distributed concept where we've got these different elements in different places. If we actually are able to connect these things together, to federate these elements together very effectively, in the control layer, as well as just signal sharing, then actually we can create a very, very seamless production environment that gives us all of those benefits we're talking about. So it gives us the ability to do higher production value, it gives us the ability to lower the cost, and it gives us significant flexibility in the way we're actually able to operate. So I hope that's helped unpack things a little bit for you. That's where I'm going to draw things to a close. I've spoken for getting on for an hour, and I think that's plenty long enough. Hope I haven't sent you to sleep. Just a reminder, if you want to check, come and find me at NAB. I'd love to talk some more with you. Stan C10901, or I'll be on several occasions in the West Hall for the IP Showcase Theatre, which is W5222. If you want to reach out to me in advance or after that, then my contact details there of my email and my cell, do feel free to do that. Also, I like always at the end of my presentations to make an obligatory invitation for a cup of tea. Now, this is a picture of my friend from Canada, Lee Widdicombe, from Imagine. And he actually gave me a call when he was in the UK about 3 months ago and said, I'm in the UK, I'm only a couple of hours away from you. Can I take you up on that offer of a cup of tea? So I'd love to even get you a nice cup of tea at NAB. I don't even know if I'm going to have my kettle with me. I haven't asked Sony whether I can bring my own kettle to the stand yet. So you might have to come and visit me for a decent cup of tea with boiling water, but I can make it for you very nicely. So that offer stands if you're ever in the UK, or maybe we can find some way to get a nice cup of tea at NAB if you're there, but I'd love to talk with you. Anyway, thank you for your time this evening. It's been great to share with you. Hopefully some of that resonates with you. Some of that has been some value. I'm very happy to take any questions or answers and talk through any topics if anyone wants to have any discussion now. So with that, Martin, I think I'll hand back to you and see where you want to go, and I'll stop sharing my screen now as well. So thank you very much. I'm just trying to find my cursor so I can stop sharing my screen. Oh, there we go. Okay, so that's me done. Martin, back to you. And I'll open up for any comments or questions. Maybe I did send everyone to sleep. I do notice there's been some chat, actually. Let me just pull up the chat. Because I've been in presenter mode, I haven't been able to
Can
actually...
we raise our hand on camera and wave?
Sure.
So yeah, I would say I don't know how to I'm very happy for people to open up the camera. So I'm just looking at what's been posted on the chat. Sorry, because I was in presentation mode, I didn't see the chat until I just released the screen. So I'm just looking to hear view of the readiness of NMOS and experience of implementations and lessons learned. Okay, that's a very good question. And I think what I would say is the control plane, which is what NMOS effectively is, did suffer being quite late behind the work that we were doing in Symption 2110, which was very specifically about the data plane. And 2110 is not really about the whole data plane. It's very specifically about the interfaces on the data plane. So it's a very, very small subset. So NMOS suffered because it was late to the party. I think it arguably became at times overly complex to implement, although I think we've got over those hurdles now. What I would say is in the last 2 years, NMOS has matured significantly in the way it's able to be used, and the adoption and interoperability of NMOS within the industry. And we're now looking to adopt NMOS in controlling cloud-based infrastructure as well. So, and indeed, the work I've been sharing on 2110 actually makes use of a constrained version of NMOS to actually do the secure control plane elements over the wide area network within that kind of DMZ environment. So I think that's very important. So one thing NMOS doesn't do yet is give you everything you need in the control plane. So even the most NMOS friendly deployment still needs other elements of control architecture to give a complete solution. So, for instance, NMOS is very good about setting up and routing, but if you want to parameterize a piece of equipment and control it, you typically are going to need to use a separate API to do that, because it doesn't have the finesse to do that yet. But it is a work in progress. So there is some stuff being worked on, which is starting to look at those control and parameterization elements, as well as the basic connectivity setups, which is what NMOS does based. So that's my answer to that question there.
I think John Schilberg has a question too, Andy.
Okay, right, John, go.
Andy, good to see you again, and safe travels to you out to NAB. I won't see you out there, unfortunately. I have I have a brand new knee that won't make the trip.
Oh,
but I'll be recovering here and reading up on everything else. But my question is this: we grew up with analog video, then SDI, and we had black burst generators.
Yep.
And we used to have sync and burst and flag, and we used to have a sync generator that had multiples of spigots on it. We got rid of that, went down to black burst, and then the tri-level sync. And now we have PTP. Now, does PTP obviate the need for us to have frame synchronizers anymore? Does it eliminate any kind of need for our plant to be synchronous? Do we just magically plug in PTP and pipe it over to our various video sources, and suddenly they're all singing the same tune and the same happy melody?
Okay, very, very good question, and I think that we could spend another hour on this. So I'll give you a couple of high-level thoughts, and then very happy to dive into that, or even do another presentation at some point on it. But in fact, one of the elements I'm looking at, what 2110-11 is going to be called is timing planes, and that's thinking about how different timing planes within a production actually relate to each other, and how you can quantify that. Because as I alluded to, largely speaking, most production infrastructure is inherently frequency synchronous now, because there is inevitably generally a GNSS reference most of the time. There are some exceptions to that, but largely speaking, you've got that. You almost always have, though, as soon as you get into that, you start to have phase offsets. So, but they're effectively, largely speaking, static phase offsets, because if you think in a classic analog, in an SDI world, let's go to an SDI, let's not go back to analog. In an SDI world, you have different elements that contribute that have a timing plane associated with them. So, you've normally everything is gen locked, so it's frequency synchronous. But for instance, the output of I happen to know a Sony Vision switcher only has like a one line, in SDI world, only has a one line delay. So you've got a timing plane that's one line late there. And then you can compensate for that in different ways. But you do know that's a static one line. So it's a static phase offset. You don't suddenly need to resync that to do other things with it, as long as you can accommodate that phase offset that you've got. And I think a lot of the work that we're doing now is actually saying, what we need to have a mindset of moving forward is not so much the concept of the finesse of, these elements of timing planes. What we need to do most importantly is to make sure the timing information associated with every video frame or every audio sample is actually preserved, so we actually can understand what that time, what the what the origination information is about the relational between not both the relational of the acquisition, but also in terms of replay synthetic sources, the intentional timing that those have with respect to each other. And as we move, what I was trying to say earlier, from a raster driven environment, which we are still completely in 2110, by the way, we are still completely driven. If you look at the timing constraints of -21, it's very, very linear, and it's still the same thinking that we've had for 90 plus years. But as we move to a more software-based infrastructure, then those timing constraints don't make sense anymore. And one of the things about PTP I've seen several people really obsess about is getting PTP into the cloud, so you could actually time things accurately. But the reality is you don't need to do that anymore. And I think the mindset of how we treat time, obviously time is still critical, latency is still vitally important. So I'm not saying they're not important, but the way we handle them needs to be done differently moving forwards. And I think that's the important thing. So without saying too much more, I'll say that there's a couple of presentations I've done on timing in the like at the SMPTE ATC last year online, and I've done a couple of those other places. So I think I did one even at VSF in a couple of three months ago. So do check those out. They have some more information, but if anyone wants to deep dive, I'm more than happy to have a session on that another point. Hopefully that gives you some nuggets of answer.
Thank you very much.
Any more?
Andrew, you got time for a question from Las Vegas here?
Absolutely, sir. Absolutely.
Yeah, things are cranking along. There's lots of activity over in the convention center. So we just got off the roof. Just got off the roof of the West Hall.
Wow.
90 degrees Fahrenheit. Sorry.
Yeah. I guess. Yeah. I dream of that temperature here.
Oh, don't wear a long sleeve shirt or a sweater. You're not going to need it.
No.
The question I have is, one of the things that's I think held up a broader implementation of 2110 is the cost of the core equipment. Whether you use a dedicated switch from a manufacturer, or you use a generic high performance IP switch fabric. These are very expensive products compared to a SDI router, even a router that can do UHD today. What do you see happening with the cost of these things? Do you see anything in the near future or the price of these things to come down a bit?
Yes, it's a very valid point, and I think which is why I'm saying I think the maths that people were talking about, like 5 to 7 years ago when we started this journey of just converting from SDI to IP. If you're just doing that in isolation, just to use a different technology within the plant, and you're not trying to leverage any of the other flexibilities, like all of those elements I had of, being agnostic to spatial, temporal resolution, bit depth, color gamma, all of those elements, audios, et cetera, and the flexibility of being able to route and doing all those other bits, then like for like, it's going to cost you more to do it in IP than it is to do it in SDI. There is no doubt about that. What I would say is the switch manufacturers are upping their game, having to handle hundreds of gigabits of multicast flows and having to do decent PTP propagation was a real shock to every switch manufacturer like 6-7 years ago. I don't think any of them would, I know I've got good friends in all of those vendors. I don't think any of them would deny that they had to really up their game and wake up to actually be able to handle very high bitrate multicast flows that just hadn't been done before, and to properly handle PTP distribution in scalable ways. And those things, have come at a price because of the kind of models that are associated with that. But what we are seeing definitely now is more cost-effective fabrics that are capable of doing what we need to fulfill these elements. And also just the simple, increase in switch density and bandwidth, etc., is itself reducing the cost per gigabit per second of connectivity significantly as well. So there was absolutely a down ramp on the cost of doing those things, and it's also important to think about having appropriate scale. And there are also other questions to make use of. So I know some of the thinking is, do we need to stay linear in a production campus, or is having some kind of mezzanine compression, especially for UHD, something that's actually appropriate? And more we're seeing cameras natively having, for instance, JPEG XS compression built in, and multi-viewers having natively JPEG XS compression built in. So suddenly we can have a 10-to-1 or certainly 8-to-1 reduction in bandwidth requirements in the UHD, and you could even apply that to HD as well. So I actually think there are several drivers, the inherent cost of fabric falling, the inherent more feature-rich fabric being available, multiple other fabrics coming on the market that can serve the requirements, plus the advent of potentially using mezzanine compression within plant as well. All of those things are driving this to become more and more cost effective. But, as I say, taking that in conjunction with the real benefits of a total distributed production system, I think is where we really start to see savings. So hopefully that gives you some response on that.
Yeah, thank you very much.
Any more? I've just seen one here from William. The man-machine architecture looked like with all the separate APIs. Yeah, very, very good question. One of the things that I've been trying to get our teams to focus on is a unification of standard ways of viewing elements and controlling elements. So so you have one golden view, if you like, that actually is able to embrace those elements. Like, we're never going to get to the perfect solution of one thing, but I think you've very much got control and monitoring, for example, and I think different people involved in the production do need different views of the system to be able to do that. The technical support people need a different view to those people that are monitoring the service in the MCR to those that are actually driving it to actually create the production. So I think there are different views that are needed. But yeah, I think the unification, and as we create more and more standardized APIs that are rich enough to support what's needed, we're going to be able to do that unification more and more easily. I think at the moment, some of that is inherently vendor specific because of the way, trying to achieve things in a reasonably quick time. But it is a challenge, but it is something that I think is going to get better and better and better as we evolve by using more standard APIs and more people being able to integrate that. But certainly one of my passions is this control plane, and actually the overarching control, and how we can make that more abstract and more simple and more unified. So very, very good point there.
Is your goal to try to make that control plane so that vendor A control system can operate vendor B equipment all the way down to shading and other aspects of camera control?
Ultimately, yes. I'm not really ever claiming that we're definitely going to make absolutely everything there, but I think we're gradually going to pick off the layers. Whether there is going to, I think invariably there are going to be some bespoke elements that are going to remain vendor specific, that are going to need to be accommodated. But even if they do need vendor specific things, the way those vendor specific displays can be hosted and integrated within a higher level package is also possible. So it doesn't mean that there has to be complete genericity, because vendors actually have USPs and value that they create themselves, which is part of their sale value, if you like. And you don't want to necessarily make people think you're destroying those. So the ability to host APIs within other systems, etc., I think is probably the way we're going to tackle some of those elements, to allow vendor specific stuff that's unique to be supported, but actually have get towards the one single pane of glass type architecture.
I think your earlier analogy about multiple planes of glass from multiple layers of personnel in the facility is actually the view that I've seen implemented before. And that seems to be the only way to do it, because you're still going to have the IT people running the switch that's going in and out of all the main facility. And unless that's something that can be handled by the broadcast engineers, that's a totally different thing. So
yeah,
it's layers, and then the production people don't know anything about that.
Yeah. And as I said, previously, the other thing that certainly I'm putting a lot of focus in with our teams that are doing dev in the control plane area is this abstraction, because you don't even want, even those support operatives don't really want to have to get their head around the nuances of really deep diving into it. They really want to be able to to be abstracted and actually see the information that's presented in an appropriate layer to what they're trying to analyze, which quite often isn't going down as far as needing to understand IP addresses. It's actually looking at the performance of a service that's running, or some flows that are running. So the appropriate abstraction, I think, is very important.
Yeah, and it's so hard to troubleshoot. Anyway, I thought your presentation was great. Thank you very much for the answers.
Thank you. Any more before I pack up and go and get into my bed here in the UK? It's gone quiet. Well, I'm always happy to take emails or questions. If any of you are at NAB, do reach out. Love to catch up with you. So thank you for your time.
Marty, go ahead.
Paul?
Right.
Andy, that was great. Thank you so much, and have a great NAB. I want to remind our Simply members that if they haven't voted in their section elections, to please do so, because that's closing out. It's very important. And please watch your email for our upcoming May meeting here in New England. We're still working on it. And I think we have a lot of people here from New York, I see, and welcome. And perhaps we'll do this again one day. I think it's pretty effective and very efficient, especially for our presenters. So, Paul, do you have anything to add to that?
Just a special thanks to Andy. It was a great presentation, Andy. I'll be honest and tell you, I think I understood about a third of it. But I think that's a pandemic problem we're all having in dealing with the new technologies. But it's good to know that there is somebody out there who is the guru, who we can all knock on your door or your email, and we'll find out. Thanks very much.
And thanks again, and thanks to everyone involved that helped put this together, from Sony and Sony Nevion, and of course, Ed Delata from the New York section. Thanks again, and good night.
Take care. Good night.